All right. Thank you for joining, Prasad. So let's start with your introduction. So can you introduce yourself? Can you talk about your previous experience?
Okay, Vivek. So I am Varaprasad. So I'm having total 5 years of experience in IT. So I started my career as L2 support engineer in one startup company where I used to work as L2 support engineer, where we get the ticket from the end users and we resolve it. So in the initial that help us to understand how production systems are run and what are the things we need to take care of in my earlier career. Then I switched to the Infosys. In the Infosys, currently I'm working as a AWS DevOps engineer. So our project is mostly on the microservices. It is a Java based application. So we provision the AWS infrastructure using the Terraform, and we build our pipelines using the Jenkins and the GitHub Actions, and we containerize a application using the Docker, and we use EKS Amazon EKS services to host those containerized applications. And to deployment purpose, we follow the GitOps based deployment. So we use Argo CD application to deploy the application on the EKS. And also we for monitoring also we monitoring and observability part, we use the CloudWatch and CloudWatch Insight, in Container Insight and Prometheus Grafana. So based on this monitoring tool, we monitor the application. So for I am a mix of the Kubernetes and support the production activity, support the productions related issues, and does the some automation. So this is my entire about myself and my experience.
So you said yet that you have worked on Jenkins, GitHub Actions, and Argo CD all together, or how is the setup that you've supported?
Earlier we used to do the Jenkins and Argo CD. On new microservices, there are few services I added in my project. On the new microservices, we use the GitHub Actions and GitHub based deployment model.
Okay, GitHub Actions. And in terms of monitoring, you're saying you use CloudWatch and you also use Prometheus and Grafana, right?
Yes. We use the CloudWatch for the AWS infrastructure like a load balancer and worker nodes. And to monitor the EKS, we use the CloudWatch container insight. CloudWatch container insight, and to monitor the application, we use the Prometheus and Grafana.
So you don't use Prometheus and Grafana for EKS?
No, we use for EKS, we use the CloudWatch container insight AWS services.
Okay. So I mean, I just want to understand, like you have two different places where you have your application metrics as compared to your infrastructure metrics. Is that correct?
Yes. Application metrics and different tool, and infrastructure is AWS side.
Any like specific reason to do that? Because like generally, like we would want to have all the things in one place so that we don't have to go to multiple places.
Actually, I'm not part of the design of these things. But as I know, my project is 10 years old, so they are closely coupled with AWS services. That is the reason they are using the CloudWatch and CloudWatch container insight.
Okay, okay, no problem. I just wanted to understand the reason. Uh, all right, so let's talk about a few technical questions now.
Okay.
I came to know about your experience. I think you have like very good experience. So let's just see. Um, so have you? Can you just like talk about the steps of a pipeline that you have managed? What are the steps that were there in the pipeline to deploy the code?
Okay. So in first step, we check out the source code. Then we build and test the unit testing and the unders. Then we have the static code analysis and Solana cube. Using these tools, so we does the if the code has any security vulnerabilities and all. Once the pipeline is passed the static code analysis, then we build the Docker image. So after building the Docker image, we scan that image using the Trevi. Once the image was scanned, we pushed that image to the ECR. At the same time, that image tag is updated in our GitOps repro. So this GitOps repro is continuously monitored by the Argo CD Argo CD application. This Argo CD applications find any image tag, any resource modification. It syncs the those to the EKS cluster. Using the for deployment model, we use the plugin rollout. So using the plugin rollout, we that new image tag will sync to the our EKS cluster. So first we do the dev and say image will push to the QA and UAT and production. So we build the image once and push the same image to the higher environments. That is why we maintain the environment consistency and all.
Okay, so you are using SonarQube for scanning your code and like finding any vulnerabilities and fixing it, right?
Yes, yes.
So can you talk about the concept of quality gates in SonarQube?
So in quality gates are a few it is a few it has some set of the rules. So the code should pass set of code, some like the code should pass the sonar cube, and it pass the all the smoke test, and it should pass it shouldn't have any dependencies or vulnerabilities and all. Once it is passed, then only we created the image. If this stage is failed, the pipeline will stop and an email will trigger to the our development team.
Okay, so okay, 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 that's fine. Uh, so you're using Java applications. So which tool are you using to build your artifact for the Java applications?
We use the Maven build. Maven we use
Maven
that.
build. Okay. And where do you store your built artifacts?
Actually, in we have a one shared library inside our organization.
Hmm.
So that is all internally. We post all the dependencies to that shared library.
Shared library. But on which platform is it hosted? Is it on cloud or is it hosted on-prem or how's it?
It is Nexus.
Nexus. Okay, yeah, yeah. That's what I wanted to know. Okay, you're
Yeah,
using Nexus.
Nexus.
Okay. All right. So you said you deploy applications to Kubernetes clusters, right?
Yes, yes, Kubernetes cluster.
And and you're using AWS, right? You said EKS
Yeah,
clusters.
yeah.
Okay. Can you talk about the different deployment strategies in Kubernetes?
So deployment strategies are one is the rollout strategy and blue green deployment strategy, and another one is secondary deployment strategy. So in our project we use the blue green deployment strategy. So we use the Argo CD uh, rollout Argo CD rollout. If you use that kind, we there is one preview service, one is active service. Active service is the application current running version. Preview service is the your latest version. So once it is previous service, so we done all the monitoring like synthetic testing, some light testing, and we take the P90 P95 metrics and all. Once it is fine, then only we then only we updated, then only we promoted that latest version to the active service. At the same time, we maintain the current version as a backup. If something breaks up, we just update the this promotion. So this is the one we are doing. In the low environment, we use the rollout deployment rollout. So in this current prods are once latest version created, then only the old versions are rolled out. So in the low environment, we use the rollout strategy. In production, we are using the blue green deployment model.
Okay. One question. So just assume that you have a pod, you have an application pod deployed in EKS cluster, and that pod needs access to certain services in AWS account where
Okay.
the pod is hosted.
Okay.
So you want to control the access of the pod to the different services. For example, I just want to give that pod access to a certain services and only read only access I want to give.
Okay.
So how to achieve that?
So to get the access from the AWS services from the EKS pod, we use the IRSA, I am role for service account. So we use so if we use this IRSA, we create the one service account inside the EKS, and we created the one IAM role in the AWS, and we use the YADC for the trust. So when we create the IAM role inside the AWS services, in the trusted policy and permissions, in the permissions we have to define the only required permissions for the what this part actions. In the permission, in the trusted permission, we have to mention, we have to map the this service account to the this IAM role and that trusted. That is how I achieved. In our project, we use the ESO, external secret operator. So whenever the pods require the secrets, external
Mhm.
secret operator fetches those secrets from the AWS secret manager and store it the cluster level. And using the secret kind, when the pod is running, we use the secrets, and it is mounted to the pods, and it's connected to the other downstream systems and the database system. So using the IREC, we can achieve.
Very good. Yeah, good answer. Okay. Now, can you talk about so just want to understand like what kind of application do you support? Is it the front end applications or back end application or databases or like mix of everything that you support?
So we support the front end and back ends. For database, we have a different team. They will handle all the migration and all. We support the front end, the back end. Back end is a Java based Spring Boot application.
Okay. So you must be having some application that is public facing and some are internal to the employees. Is that so?
Yes, that's correct.
Okay. So just assume that you are working on a front end application that is publicly available. So, can you talk about how the traffic from the user's browser is entering your, uh, you know, uh, your company's infra and then to uh, EKS cluster and then to pods and then to the container? How that entire traffic is flowing? Can you talk about that?
Sure, sure. So when user hit our application, first the traffic route 53. In the route 53, we have our application load balancer DNS. This application load balancer will be created from the Ingress controller, which is in the EKS. So in the application, in the once it- though the so the traffic is in the Ingress controller, then we
Hmm.
have a Ingress. In the Ingress, we have some configuration rule. So suppose
Okay.
the path is a slash home, the traffic will route to the home services pod. Suppose the path is a slash service, the the traffic goes to the services. Then so the traffic reaches to services has this pods endpoint. So
Hmm.
in this way, the traffic reaches to these pods from the application, from the route 53 application load balancer services and pod. This entire traffic route from the user to the pod.
Okay. So I want to ask another question here. Suppose your backend API, which is part of your application, uh, it wants to talk to the database. So I mean, how it can achieve a Kubernetes setup? How the backend API can talk to database in a Kubernetes cluster?
How backend away traffic to the database.
Yeah.
So for backend pod, we use the config map and secrets. In the config map, we mentioned that this database URL. In the secret, we in the secret we in the secret map. So as I mentioned, we use a ESO, external secret operator. This pod fetches the secret from the external secret operator, and it's connect to the database using the config map and secrets external secret operator. My backend pod is connect to the database.
I'm talking about the networking part, how the traffic is routed from the backend API to the database.
How traffic route to
Yeah.
the
In a EKS cluster. So you are using EKS cluster. So how the backend APIs are talking to the database inside the Kubernetes cluster, inside the EKS cluster in our case, how that is happening. Which component of Kubernetes are you using there to achieve this?
for that we have a service, external service. If we use that service, we can hit to the backend API. So I'll
But
go
okay,
on. Go on.
But why do you want to use an external service to access the database? Should it not be internal?
It should be internal only.
Okay, anyways, no problem. All right. Let's move on to the next question. Okay, you spoke about GitOps also, right?
It.
So can you talk about like what is the fundamental concept of using GitOps? Like why do you want to use it in the first place?
So if we use GitOps, it controls to monitor the our backend repos, and it directly syncs the those if we find any drift, if we find any change, it automatically syncs the those repro changes to the EKS cluster. So suppose if we don't have the Argo CD, just we use the our pipeline stages, we have to give the our AWS credentials and all. And every time we have to every time we have to create the new pipeline to make changes to this. Suppose someone is manually changes manually has made any changes in the EKS cluster, we don't know. But when you use a Argo CD, if someone has made any manual changes, it's compares what is in the GitOps, and it override if you enable the auto sync features. So it's provide the it's decrease the operation at the headache and more of flexibility if you use the Argo CD applications.
But I mean, from where the your GitOps tool is trying to sync, where is that source? Which source
Source
are you
is
talking about? Yeah.
source is our GitOps repro. Source is our GitOps repro. It's converts the monitor the our GitOps repro. We have one GitOps repro where we place the, all our YAML files, or Kubernetes YAML files, and here some re-emulated YAML files. It mounts that's the source file and syncs to the EKS cluster.
Okay. Which platform are you using to store your repos, your source code management platform?
GitHub. We use the GitHub.
GitHub. Okay. One question. So suppose you are working on some deployment. Okay, you have EKS cluster, you have your applications CI/CD pipeline running, and now suppose the pipeline has failed on the deployed stage, which means that your changes in the form of container image. So that has been deployed to the EKS cluster, and that deployment has failed.
Okay.
And you had like three pods running at that time. So three pods running with the earlier version of your code, basically.
Okay.
And now this new image has failed at the deployment stage, and this new pod has failed.
Okay.
So in this case, suppose you're rolling like you're using the rolling update strategy, for example, to update your deployment. Okay. So I mean, all I'm saying is you have an EKS cluster where you are deploying your application via the deployment.yaml file, and there you're using a rolling update strategy to roll out the versions of your deployment, the different versions. Okay. And
Okay.
now this new image that was built in this last code changes, that has failed at the deployment stage where the new pods come up at that time. So that new pod has failed,
Okay.
and you want to roll back now. So I mean, how do we roll back in this situation?
We use a Argo CD application. If you go to the Argo CD UA, we have a option like a rollback some options like a rollback to previous version, and I will select the that thing. And also if I want to, and in one of the way I can go back to the rollback. And also I log into the EKS cluster and run the kubectl undo rollback and deployment version. If you run that command also, I can go back to the previous version. So running the commands, and also go to the Argo CD way, I do the rolling.
Okay, are you using Helm anywhere in your CI/CD pipeline with GitOps? Helm
Yeah,
charts?
we use the Helm. Using the Helm only, we generate the one final manifest file, and the Argo CD syncs those final manifest file to the EKS cluster.
Okay, so then like why do you have to like use the kubectl like command line if you have the Helm versions to like update to the newer version or to roll back? Why do you want to use this kubectl version when you have the last deployed Helm chart version that you can use with your the CI/CD pipeline?
I just giving the options I just giving the options. I can also go to the EKS cluster and I run the this command. Mostly, if I want to do the any rollout feature, I have to go to the Argo CD application and just click on that rollout banner. That's it. I'm just providing the options in how many ways I can do the rollout.
Okay.
Okay.
Okay. Can you talk about, have you ever worked with stateful sets in
Yeah.
Kubernetes?
Yes. I work with stateful sets.
Can you talk about a few differences between a stateful set and a deployment?
So stateful set required for the data holding application like databases and Grafana, and deployment is for the stateless application like front end pods and all. And if you use the stateful set, the pod, the even though the pod is recreated, destroyed, it will come up with the same identical name. But when we use the deployment set, the random pod names will come up. This is the main difference between the stateful set and the deployment. And also, if you use the stateful set, PVPVs are required, but for the deployment, PVPVs are optimal. Neither it's depend. If the front end application needs to hold the section details, I can use the PVPVs. It is just optimal, but in the stateful set, PVPVs are required because it having the storage and data and all. So the main difference is the pod identical should be same even the pods created in the stateful set. The pod identical random, and it will come up with a new name if you use a deployment. For the stateful set, we use the service as a headless services, and there is no service. So when the request route to the cluster, it will route to the all the three pods. And in the deployment, we have a different type of services. So like if you use a normal service, it has a capability of the load balancer, and in the so the traffic will route to the pods based on the round robin way. So that is the main difference between the deployment and the stateful set.
Okay. Let's talk about some fundamentals now. Can you talk about a pod's life cycle? Like you want to create a pod, and it has to go through the different stages to be scheduled in the cluster. So yeah, can you talk about its life cycle?
So initially, the pod is in the scheduling stage. When a scheduler find the suitable node for the pod, then we'll change it to the running. If it is has any issues based on if the pod is while run before the pod is come into the running state, if it is have any issues, based on the issues, it'll come up with some different errors like OEM kill cache backup for image pull backup as container create configuration. And once the pod is running, based on the probe, based on the if a readiness probe will pass, then only the pod status come to the ready. So initially the pod is in the schedule, then running, then ready state.
Okay, if I just ask you this question, what is the first thing that happens in the cluster when you run a command? Uh, so for example, like you want to create a pod and you have a deployment.yaml file and you are doing kubectl apply -f deployment.yaml file.
Okay.
So what is the first thing that happens just after you run this command?
So when you run this command, first it to the API server. The API server does the authentication authorization. Then the pod manifest file is stored in the etcd. Then we have a scheduler. Scheduler finds a suitable node for this pod based on the node ephemerity and the request and all. Then it's find the suitable node, and it's give to the those and it's give to the API server. API server updates the node spec in the node spec of the pod that is in the ECDD, and every node we have a kubelet. Kubeleted continuously monitor this API server and fetch the image from the ECR, and it's trigger the container runtime, and the pod is created.
Okay, okay, okay. So you have also worked with Terraform, right?
Yes, it's Terraform.
Okay, so can you talk about like what happens when you run Terraform init command? What are the things that happen behind the scenes?
So when you run the Terraform init, in the provider TFL, you mention the which cloud provider it is using. So it is not,
Mhm.
it is download the that it's download the that cloud providers and all.
Mhm.
And also it also invoke the Terraform backend if you use the Terraform backend. And so when you run the Terraform init, it's connected to the it's download the API to the APS to connect with that cloud like AWS and Azure. And also it initiate the Terraform backend.
Okay. Okay. So you spoke about backend. So for example, in AWS, you're using S3 bucket
Yes, yes.
as your remote backend. So like, what are the some of the advantages that you get with
So
this?
if you use the
Hmm.
S3 bucket as a remote backend,
Hmm.
it is for team collaboration. Suppose if we place a state file in the local, so if Terraform is a state file is a single source of the truth. It
Hmm.
contains the resources and resource information and dependency graph. So if the two people, if suppose the state file is in the local, if the two people apply in the Terraform apply, so it will corrupt the state file. But when it is in the remote backend and apply in the proper logging, so if you apply in the proper logging, suppose two engineers apply in the Terraform apply, it will log the first who apply the Terraform apply. So in this way we can control the Terraform. In this way we can control the state file corruption and all. And also when you use the remote backend, we can also enable the versioning. So it will provide the, if anything, if someone accidentally deletes the Terraform state file, we can have the version, we can easily go to the versioning previous versions. So when you paste the Terraform's state file local, we don't have any versioning and all. That reason that reason we use the remote backend to store the state file for the versioning and proper locking and for the team collaboration purpose.
Okay. Okay. One more question on Terraform. Suppose you have created a security group via Terraform. Okay.
Okay.
And it has been like properly synced to your state file wherever it is. It is stored on S3 bucket or it is stored like locally. It doesn't matter. Now somebody has added one more inbound rule to the security group manually from the UI from
Okay.
your uh, AWS Management Console, and now you are running Terraform plan. So what will happen? What will you see there in Terraform plan?
If someone manually updates any infra in the AWS, when
Yeah.
you run the Terraform plan,
Hmm.
it will show the drift. When you run the Terraform plan, Terraform compares the what is in the actually in the AWS and what is in the config file. So it will find that drift. If I find the drift between these
Hmm.
two,
Hmm.
then I go to the AWS console and check whether it is a authorized change or it is a unauthorized change. If it
Hmm.
is an authorized change, I update my configuration file and I run the Terraform apply. If it is an if it is an unauthorized change, I straight away run the Terraform apply. If I run the Terraform apply, what is in the config files in the that will automatically override this security group changes. So I'll find it is a authorized or
Hmm.
unauthorized. It is a unauthorized. I'll straight away run the Terraform apply. If it is the authorized, I'll just update my config file and run the Terraform apply.
So when you say
In
you, Mhm. so
in our
mhm.
country.
So when you say you like update your config file, so like what does that mean? Like what do you update?
So in the main.tf file, I update the what is in the latest in the AWS that change in that main.tf file,
Hmm.
and then I run the Terraform apply. It is,
So you're saying you will just like I mean add the code for that change in your
yes, yes,
main.tf file and then you run apply command, and like it's going to sync to that, and it will show no changes, right?
Yes, that's correct.
Okay. Okay. Uh, let's talk about some more important questions. Like, can you talk about any like production outages that you have handled? Like, what was the issue? What was the impact? And like, how did you handle the entire situation? Can you talk about that?
Yeah, sure. So comment recently we have one service where end user will upload some files too. So if the end user upload those files, it will store to our S3 bucket. So after the deployment, end users are reporting that when they're unable to upload the documents to the applications. So we have a L2 support team. That L2 support team will start the bitch call, and I join and I join the that call along with the development team and platform team and all.
Mm-hmm.
So at initial time, development team identify some 404 error in their application logs. We use the ELK to store the application logs.
Mm-hmm.
They find this authorized issues. So they ask me to do it is a IAM role issue and update that IAM role permissions. And I check with my managers and costing and our PMs, and I take the approvals from those, and I updated those permissions, and issue got fixed. And because I done these changes in the AWS console, so we shouldn't make any changes directly in the AWS console. If we make the changes, we should inform to we have made these changes to our platform team. So we inform to the platform team these things are these things we changes in the AWS console directly. We need to update our Terraform config file, and they when but they responded back that there is no any recent change in the IAM role and in IAM policy. So the issue is something else, and then try to troubleshoot the issue further. Like that information we got from the platform team. Then again we started the call, and again I explained this scenario to our development team and all, and we continue, and they our PM suggested to do the quick rollback, and we do the quick rollback. After Sunday, one formal email take the approval and all, and when we do the quick rollback, the ban that when the issues got fixed. So end user will try end user will able to upload the documents to the application without any issue. So development team continuously development issue check the issue further. They identify that some S3 bucket compatibility issues. Because of that issue is raised, they'll fix that compatibility issue. Like they use the old version of the AWS SDK version. Due to that, the issue was raised, and they updated the latest AWS SDK version, and the issue was fixed. And after that, we have a call with the development team and QA team and all. So what our application owners and application teams application managers has suggested to us, so created some alerts on the every banner but buttons on the application on the application on the DevOps and SRE point of view, and inform to the QA team to run the some integration testing and runtime testing, and also inform to the our development team to check the release notes on the our in the shared library. We use the shared library Linuxes, so they request to check all the release notes before updating the anything. So that is how issue got fixed.
But why did you make changes like by the UI when you have Terraform to like, make the changes?
Sorry, I didn't get you.
I'm saying, why did you make changes via UI when you can use a Terraform in the first place?
Yeah, in that call, actually I was in the call. So actually he shouldn't done any directly changes in the AWS
Hmm.
console. I should go to the Terraform. But it is a impact in the business, and also it is almost and also we need into our SLA. That is the reason I done those changes. But we can update the Terraform config well in, so that's the reason I made changes later.
Okay.
But in standard process we should not make any changes directly to the AWS. But it's also if it is impacting we can do. It's that is the reason I take the approvals from the all the team leads and managers and all. Then I do the changes.
Okay. All right. So let's talk about something related to monitoring. Can you talk about some dashboard metrics that you monitor for your applications? What are some of the metrics that actually are useful to monitor the health of your applications?
So in our project, we monitor the application at different levels. For the AWS infrastructure like EKS worker nodes and load balancer and some other AWS service, we use the CloudWatch. For that we take the rate method, CPU, memory, and disk, and network throughout network flows from the resource to resource like EPs to ACs and all. We take all these metrics and we created the alerts based on the SLO and SLA and SLO things. And at the it is at the AWS info level. On the EKS node, we created the we take the pod metrics at the at the namespace level using the CloudWatch container insight, and also we monitor the API server, how much time it is taking, whether requests are created, and scheduler whether schedule is having any issue, and like that thing we have taken the those metrics. And application point of view, and our application point of view, we get the alerts and take the metrics like on the traffic, request, error rate, latency, and all. So that is one metric.
Okay. Any specific application metrics specific to Java applications that you need to monitor?
Actually, we have a one payment service. So we have the payment service. So we have to find whether payment is success or not, and also we take the how many it got success, how many it is in the queue, like that thing like that thing metric we are taking.
Okay, no, I'm talking about specifically to Java applications that like we have certain these metrics that are standard across the globe. When you are using Java applications, you need to monitor those metrics to have a healthy Java application. I mean, to see whether your Java application is healthy or not. So, like, can you talk about
One thing
some
is
of those
the
metrics?
memory leakage and heap usage. We take these two metrics of that from the application for Java based applications.
Okay, okay. So just assume that you are working on one HPI, okay, like a high priority incident, and the issue is related to your application's API latency.
Okay.
So, I mean, how would you start troubleshooting the issue? How would you start troubleshooting a uh, API latency issue?
So if there is any API latency issue, first I'll go to our Grafana dashboard and check the when it is a latency started. I'm looking for the time range when it's starting, and also if I find the time duration, I'll check the if any recent deployment has been happening in the system, and that is one point. And second point, if it's API latency means if any other downstream systems are down having any issues, and also I will check. And also I go to my Argo CD application and I check if any my pods are in the having any issues like cache loop backup errors, and any image pull backup errors, and it is stuck in the pending. If the pods is in the any these stages, we might see the this API latency. And also I'll check the what is the ready status, whether the pods are ready or not. If it is not ready, the traffic is won't reach to these pods, because of the if it is not ready, the service will remove this part from the endpoints, so traffic is won't reach the this. And also I'll log into the pods by running the kubectl exact IT and that pod name, and I'll try to connect with the some other downstream systems, and I'll do the some connectivity test like by running the ping command, and I do the DNS resolution by running the NS lookup. These are the things I'll do if I report any API error issue. First I take that time, and I'll, if it is first I when first I take when issue started, then if there any deployment and I go to the EKS cluster, this path I'll follow.
Okay, so just assume that your application is facing latency, okay, at any stage, and you have like certain path of your application request. For example, I mean, if your user is trying to access the application from there to the Route 53 and then to the load balancer via Ingress, and then inside the EKS cluster to a service and then to the pods. So like, I mean, if you want to track like, I mean, where's the latency happening? At which stage of this entire traffic flow it is happening? So I mean, how would you do that?
Okay, so to want to see in every hope having any latency.
Yeah,
Yeah.
yeah. Yeah. How would you trace that?
So we have a some requested time. For the request, it has to complete the this amount of time, and also we have a request time on the every component level. So if when I go to the our monitoring dashboard, and I see what is the average request time,
Hmm.
and if it is if it is observed any that deviation on the every hope, and based on that findings, I will find there is a component having issue. That reason we are facing the latency.
Okay.
That is how I troubleshoot the issue.
Okay. All right. Next question. Have you heard about OpenTelemetry in observability?
Open
OpenTelemetry.
development.
Yeah, OTEL.
Yeah,
Okay.
I,
What do you mean
I,
by that? What do you mean by OTEL or OpenTelemetry? Why it's
so
required? Mhm.
it is a open telemetry. If we use the this open telemetry hotel, uh, we take the logs and metrics from the EKS, and we can connect with any other any other tools like Prometheus, and it is also it is not a it is not related to the platform. It is like an independent one. We can directly connect with. That's what I'm aware of it. Open
Okay.
telemetry.
Okay. No problem. No problem. Can you explain like what is the meaning of error budgets in observability?
Error budget. Suppose we have a SLO, serviceable objectives. So where we can where based on the SLS serviceable indicates,
Hmm.
uh, we are informed to we are giving assurance to the end users this much of the this much of the time, and this much of the errors this much of the reliability we can provide from our application. It's a by taking the some error from error budget kind of thing.
Okay. Have you ever handled 5xx errors for your application, for your Java application?
Yeah, I handle one many 5x errors in my applications.
Okay. And how do you do it?
If it is a 5x error, it is a server side issue. So first I'll check the request load part from the having load for having any errors in the load balancer by running the kubectl, describe the ingress and ingress and having any errors, and also then I'll check the whether ingress rulebook having the correct configuration, correct service routing
Don't you
information.
have any dashboards for this to see on a dashboard, like how many like 5xx errors are happening for my application per minute, like that?
We have created the tile for these 5x errors, where I can see if any 5x
Hmm.
errors,
Hmm.
we get notified from the our we get notified from the CloudWatch container insight for the what is the way, which part and which namespace, and how many parts are in 5x errors. So based on that we find the exact pod namespace. Then we do this request path. The pod having any issue connected with any other downstream systems, the pod having any OM kill any cache back errors, and sometimes we check the logs of the pod, whether it is having connectivity issue to connect with the database and any other down systems. These are few reasons that we see the 5 XRs.
Okay. Okay. No problem. Next question. Have you ever heard about alert fatigue?
Alert,
Alert
alert for the
fatigue. Yeah.
false alert,
Yeah. Kind of. Yeah.
false.
Yeah.
Actually, I'm here, but I didn't work
Hmm.
on those.
Okay. Okay. No problem. Okay. One more thing I want to ask you about. Uh, can you talk about some probes that you can configure for your container inside a pod?
We have a three types of prop. One is the startup prop,
Mm-hmm.
second one is the readiness prop, third one is the readiness prop. Readiness prop check whether pod is running, whether having any issues that it's hanging inside. So based on the if it is having it is having any issue, the Linux prop continuously restart that pod. And second one is the readiness probe. Readiness probe check whether the pod is a state accepting the traffic from the end users. If it is if it is a readiness probe is failed, that the pod will be removed from the service endpoint. That the traffic is won't reach to the uh, uh, unhealthy pods. And third one is the startup prop. Startup prop for a few application booting time is a very take some time. So for that time, if you use the startup prop allow sometime that container take the some time. Then only once the startup prop is will check and verify. Then only like Linux prop check whether the pod is alive or not. So
Okay.
that is that is the props we have in the case.
Okay. All right. I'm almost done with the interview. So one last question I want to ask you about. Like, what do you think about the impact of AI on DevOps and SRE roles? What is your view about it?
Yeah, actually, we in our organization also they have one platform, Topaz platform.
Hmm.
So this Topaz platform where we created our AI agent, but even we created the AI agent, it will gone through the all our metrics and our rule books and all, and of the human intelligence is required because who provided those ticket to the AI agent, we only provided. We are giving we don't give any read access to our infra. We just give the read access to our agents to check whether it also it check initial stage. It didn't go to the deep. So end of the day, even in the SRE DevOps AI automation uh, required, but human intelligence are required. And that
Hmm.
it's something
So you think that AI is our friend and not an enemy, right? That's what your view
we
is.
we need to work along with AI.
Mhm.
That's what I'm saying.
Along with AI, okay. So just one more question I had, like whether you have like built any AI-based observability platforms yet in your company?
Yeah, I am trying to build on the dev environment that is in the discussion stage. Once, to check the these logs, and also we have created one FinOp agent in the dev environment. What is the bill of the AWS and the service level, on account level and namespace level? We are creating this agent in the on our low environment. It is not moved to the production environment at all. We are just figuring out how with this AI will help us to.
Hmm.
We're just
Okay,
figuring.
okay, all right. Okay, I'm done with the interview. Do you have any questions for me?
No, no, Bhumak.
All right. Thank you, and thanks for being a part of the interview. Thank you.
Okay.
And before I go, I would like to talk about my YouTube membership program where I have a lot of premium videos available. As you can see right now, I'm talking about a production Docker file. So this is a sample Docker file from a production environment, which I'm covering here, and I'm explaining each and every instruction that is there in this Docker file. Apart from that, I also have videos on some of the most important site reliability engineering terms that are often asked in the interview. How do you explain that? I have video on SRE golden signals, which is very critical when you're actually working and you're configuring some dashboards for a particular application. So you would need SRE golden signals. And then I have a hands-on project on SLI, SLO, SLA. So I start with the theory, like how do you explain these terms and how do you explain an end-to-end project that you've done on SLI, SLO, SLA. So that I've covered here. Here you can see I'm using a Java Spring Boot application, which is being monitored using Prometheus and Grafana tools. And the application is deployed into AWS EKS clusters. Apart from that, I also have video on distributed tracing with Grafana Tempo, and I also have one video on how do you use OpenTelemetry for metrics collection for a Java Spring Boot application in Prometheus and Grafana. So it's again, all these videos are hands-on, which means that I'm going to share the document, the end-to-end document that I'm following here, and how do you configure all these things in real. So all that I'm trying to cover here. Apart from that, I also have video on logs aggregation using Grafana Loki tool for Java Spring Boot application. So how do you aggregate logs from multiple applications into Grafana Loki? So that I am covering here. Then in production, we don't use the standard Prometheus to collect our data. We use an enterprise solution which is called Mimir. So the difference between Prometheus and Mimir I've covered in this video. I also have a shell scripting crash course with production scenarios where I'm going to talk about the type of question that are asked in the interview. Apart from that, all the fundamentals of shell scripting that you should learn for the interview. Then I have other videos as well. As I mentioned, I have multiple videos on Prometheus and Grafana based Java Spring Boot application monitoring in production, how it is done. So these are the videos. Apart from that, I also have Terraform, I have Kubernetes, and I have AWS, Linux, and you can see some of the videos in my YouTube membership program are actually recordings from my real live batches that I've run for SI trainings. A lot of people have got the job as well. So I have these recordings as it is, and in each of these videos I'm talking about how it's going to look like when you're actually working in real as an SRE. So I'm talking about all that. Yeah, so these are the things that I have on my channel, so you can take a look at it. If you find it useful, you can go for the membership as well. It's going to immensely help you in your interviews. All right, so that's all I wanted to cover in this video. I hope this video was useful to you. If it was, please hit the like button. Please share this with others. Please do subscribe to my channel and keep watching my channel. All right, guys, that's all for this one, and I'm going to see you in the next one. Bye for now.